What's up everyone, welcome back. Patrick here. Moving on to the next video. We have a word problem to deal with. So we're told a ball is thrown off a roof and its height is modeled by this quadratic, negative 2t squared plus 12t plus 32, where h is in meters and then t is in seconds. So what we got to do, we got to find the height of the roof, the max height of the ball, the time it reaches the max height, the time it hits the ground, and then also we have to discuss the valid values for h and t, because notice this is a quadratic. It's just an abstract quadratic, but then when we apply it to a word problem, there's going to be certain restrictions for the h and t. So the restrictions actually are going to be the time can't be negative, height can't be negative. So actually what I'm going to do is, to start off here, I'm going to just actually graph this quadratic in an abstract format. So let's just pretend that there is no word problem for now. And let's just pretend you're asked to graph this quadratic. If you want to make it super abstract, you could even put in y over here and then put in x's for the t's. I'm going to keep it with these variables. So let's just graph this. What are some characteristics we can get? Well, notice we can get the y-intercept or the h-intercept. In this case, we could plug in 0 for t, and notice that because this is in standard form, the y-intercept or the h-intercept is going to be the c value, right? Because if we plug in 0 for t, we would end up, this expression would go to 0, this expression would go to 0, and then we just left with a 32. And so that's actually the answer to part A. That's how high the roof is going to be. But let's draw the diagram first, and then we'll go into answering the questions. So again, we're just working with a quadratic. Forget about the scenario for now. Let's just get some characteristics for it. So we have the h-intercept. What if we wanted to get the t-intercept? Well, what we would have to do is we'd have to plug in 0 for h and then solve for t. So how can we do that? Well, let's see if we could factor this. So just on the side here, we got that quadratic. So when we factor, what's the first thing we check for? Can we take out a greatest common factor? And notice that we have a negative as the leading coefficient. So we'll take out a negative, and then also notice we could take out a 2 from all of these. So what would we be left with here? Well, we would just divide all these expressions by negative 2. So the negative 2's would cancel out here. We'd have t squared, 12t divided by negative 2 gives us negative 6t. 32 divided by negative 2 would give us negative 16, like that. And then what we can do is this remaining bracket, so let me actually write this up here, just because I want to keep everything on the whiteboard. So what we can do is this remaining bracket, we can see if that's going to factor. So we got t squared minus 6t minus 16. So what we could do is see if it factors by decomposition. So notice that the a value is 1, the b value is negative 6, the c value is negative 16. What's the ac value? It's negative 16. And then what we do is we find two numbers that multiply to negative 16, add up to that b value of negative 6, right? So what would those two numbers be? It would be negative 8 and 2, negative 8 and 2, right? Negative 8 times 2 gives us negative 16. Negative 8 plus 2 gives us negative 6. Okay, and because this a value is 1, we actually know that the final answer is going to be these two values. Again, as I mentioned a bunch of times in previous videos, that's not always going to happen where this a value is 1, but when it is, then you know you got a little shortcut right there, right? It's just going to end up, those two values would end up going here. But if your teacher requires you to show the full work, let's do the full decomposition over here. So we decompose that b value, then notice we could take out a t, then notice we could take out a 2. Okay, when I'm going through this quickly, I'm assuming that you've watched all of the decomposition videos up until this point, that you're fairly comfortable doing this. If you haven't, make sure you do. If you're watching this on YouTube, you can go to the description box. There's a course link there where all of the videos are in order. All right, so notice that whether we do it the shortcut way or the long way, we end up with that same factored format. So this bracket factors into these two, right? This bracket and these two brackets multiplied are the same thing. And so let's actually write that down here. And now what we could do is we could take this and come back to our equation over here. So we got negative 2, t minus 8, t plus 2. And now that this is in factored form, we could solve for those t values, right? So notice that when is this right side going to be 0? Well, either when this bracket is 0 or when this bracket is 0, right? So that's going to happen at a t value of 8. This is going to happen at a t value of negative 2. So those are the two t intercepts. Now I know that because we're dealing with a word problem, time can't be negative, but as I said, let's keep it abstract for now. Let's just draw the characteristics out, and then we'll go to the questions. So those are the two t intercepts, meaning that at those two t values, the h value is going to be 0. And actually, this answers one of the questions, the time the ball hits the ground, right? It's going to hit the ground, the height's going to be 0, it's going to happen at 8 seconds. But again, we'll come back to that, but thought I would give you a nice little preview. So those are the two t intercepts, or the x-intercepts if you change the variables to keep it super abstract. Now, what else can we find? We have the y or the h-intercept, the two t-intercepts. Notice that we could find the vertex as well because we have those two t-intercepts. If you remember, the vertex is going to be, or at least the t value of the vertex, the axis of symmetry is going to be between those two t-intercepts. So we can say the axis of symmetry, in this case it's the t value of the vertex. It's going to be the two intercepts added together divided by 2. This would be 6, that's going to be divided by 2, which would give us 3. Right, so we end up with a 3. So that's going to be the axis of the symmetry, or the t value of the vertex. If we want to get the h value of the vertex, we could take that t value of 3 and then just plug it in over here. Okay, so hopefully you're following along with what I'm doing here. I'm going kind of quick, but I feel like it's not too bad of a pace. So here, what we would have is what? Negative 18 plus 36 would give us positive 18, right? Yes, plus 32, which would give us 50. Right? Let me just quickly double check my algebra. Yes, it looks all good to me. Right, so that's the h value of the vertex, just a nice round number. And now we have enough characteristics here to make a graph. So let's make this graph over here. So notice that, first off, let's start off with this h-intercept. So notice this is going to be the height, this is going to be the time. So at a time of 0, we got a height of 32. So this is at 0 and 32. And then notice also the intercepts. We got negative 2 right here, and then we got 8 right there. And then we have a vertex at 3 and 50. So that's going to be like, let's say here, and then let's say 50 is up here. Okay, I'm trying to keep this to scale as much as possible. So what's going to happen is this quadratic is going to go through that intercept, it's going to reach that maximum or that vertex, and it's going to come back down like that. And we know that the vertex should be a maximum because that a value in the standard form is negative, meaning that the quadratic is opening down. So that's the abstract quadratic, right here. And it actually continues to go on forever. I just stopped it there because we know that the h, the height, can't be negative, right? This axis is representing the ground. But what else, in order to apply this quadratic to this scenario, what else do we got to get rid of? Well, notice we got to get rid of this portion over here, right? Because time can't be negative, right? We're throwing the ball off a roof, and then the ball's coming down and hitting the ground right there, right? So just recognizing that that portion is not in the graph for the word problem. It is for the abstract quadratic, but not for the word problem. So that's actually how I recommend you graphing or doing these word problems, is taking the quadratic, working with it in an abstract sense. So just graph it. Just pretend like you were given that quadratic and asked to graph it with no problem attached to it. And then adjust the quadratic according to the problem with what makes sense. So let's actually start off, before getting into these characteristics here of the word problem, let's start off with the valid values for h and t, because that's what we kind of adjusted here. So notice that for t, what are the valid values? Well, the graph goes from here to here, right? So it goes from 0 to 8 seconds. So the valid values for t are from 0 to 8 seconds. Okay, another nicer way to show this, your teacher may just be doing this. Maybe they might talk about something called a domain. If they don't even worry about this, but in case they do, basically t can be anything as long as t is between 0 and 8, right? This is more like a grade 11 concept, but your teacher may go over this. So they may just want this, or they may want that. So either way that works. What are the valid values for h? Well, notice the height can go from 0 to 50, right? The height can't be negative. So the height can be from 0 to 50, right? So those are the valid values for h. The name for the valid values for the independent variable or domain for the dependent variable, it's called the range. So that would be basically h is an element of real numbers. It could be any number, that's what this means, such that h is between 0 and 50. Again, if your teacher's not covering this notation, don't even worry about it. You could just put this over here. They may not even be covering valid values in general, but basically what it means is the valid values are adjusting the abstract quadratic to the word problem like we just did with that diagram. Right, so that's the answer for part E. And then we can actually just go through with our diagram, go through all of these fairly quickly. What's the height of the roof? It's right here. At a t-value of 0, it's going to be 32 meters. The max height of the ball, 50 meters, right? Up here, it reaches a max height of 50 meters. The time it reaches the max height happens at 3 seconds, right? Which was the midpoint between the intercepts. And then the time it hits the ground, it would be over here. It's going to hit the ground at 8 seconds. And that's it for the question. So again, graph it out first in an abstract way, then adjust it to the word problem, and then go through and answer the question.